I don't know why it's so dark all of a sudden. It's weird. Okay, this is number 20. 20 is the hardest one, hands down, on this whole thing, because we're still using the definition. So we're plugging into the whole limit as h goes to 0 of, it's usually f of x, but in this one I'm going to go ahead and write g of x plus h minus the original g of x all over h. That's the formula that we have to use. So here we go. Limit as h goes to 0. I always highlight what I'm plugging into. That's super important. So, this up a little bit. It's too close, too close. All right, so first I need g of x plus h. So I'm going to replace that x with x plus h, quantity cubed, minus g of x is the original, all over h. So it seems so easy, right? Except when you take care of this x plus h quantity cubed, you have to either multiply that out, because you really have x plus h times x plus h times x plus h minus x cubed all over h. So you can multiply that out. So we just did one on number 19 where we had to FOIL and do x plus h times itself. So it's that, but then you have to do it again times another one. So you can FOIL that out, or you can remember, I taught you guys binomial theorem. Do you remember the binomial theorem from first semester? By the way, there's this minus x cubed. I'm going to write that way down on the end here. So here's what I taught you guys first semester, because I know in class I'm going to FOIL it out for you. So I'm going to do it the other way. But I want to remind you guys that I did teach this. When you have a binomial raised to the third power, it's going to create a situation where you have 4 terms. 1, 2, 3, 4. 4 terms. And remember that there are coefficients in front of those 4 terms. Those coefficients come from Pascal's triangle. Do you guys remember this now? Do you remember Pascal's triangle? How we generate that? This is awesome because we're just using so much of the stuff we learned. So the coefficients in front of this is 1, 3, 3, 1. Then I taught you to take the first term, and it's going to be raised to the highest power, degree 3. And then each term, it's going to drop down 1 until there's none. And then I taught you the second term, the h, is going to start at the end to the highest power, and you're going to back up, and it's going to drop down 1 until there's none. And you can tell you did it right because all the exponents add to the 3. And then you just put plus signs in between them. So there is what you get when you distribute or multiply those together. Ta-da! Of course, you could just FOIL. I just like to show off and use binomial theorem. So we have this. What do you notice? The x cubed and negative x cubed cancel out. Do you also notice that all the terms that are left all have an h? There's an h squared, an h cubed, and an h. So that h cancels, one of those cancels, one of those cancels. Whew. Limit as h goes to 0. We have a 3x squared plus 3xh plus h squared. That's what we have left. Now we can plug in the 0 for h. So I'm going to put a 0 there and a 0 there. Well, a 0 squared is 0. A 0 times anything is gone. So the slope is 3x squared, but it asked at 1, 1. So we're going to plug in a 1. So 3 times 1 squared is 3. That is the answer to number 20.